Hi, everyone. Good afternoon. Real full audience. It's good to see. There's a lot of interest here. Maybe people will shuffle in. But you know what? That means it's a little bit more intimate. We can be a little bit more open. We'll tell you things that we normally wouldn't say. And we can just get started from that. So my name is Corey Sanders. We're going to be doing a little presentation here today talking about SQL Server high availability on Windows Azure. My co-presenters here, I've got Luis Vargas and Sanjay Mishra. And we will be going down through the three of us. I'm going to start by giving a little bit of some Windows Azure overview, some content about how Windows Azure works, just a little bit. And then we'll dig into sort of the more interesting content about SQL running on Windows Azure, and then some customer experiences and deployments that we've got as well. And so that's kind of how we'll work this today. So without further ado, let me just jump right in here on the Windows Azure overview. So what we're looking at here is the combination of Windows Azure and SQL Server. I have 2008 here. We also obviously have 2012 as well. It's actually a logo mistake. My apologies. So the combination here of Windows Azure and SQL Server. It's an important point to point out that, and I'll mention this a little bit more later, we are focusing on SQL Server running on a VM. Windows Azure does have an offering called SQL Databases, which is our platform as a service offering. And we're not going to spend too much time on that today. And so if you're looking for interest in that, there are other sessions that you may want to attend. Today it's going to be focused on SQL Server. And the main reason why you probably consider SQL Server on Windows Azure versus SQL Databases is really all about that 100% on-premise compatibility, right? So you're trying to run a database in the cloud with the agility that you get with the cloud, but with the compatibility that you get with SQL Server. And so all of your applications just work. And so when you look at sort of why you'd think about doing this, it does come back to that big premise that we've been pushing and thinking a lot about, which is this cloud OS workload mobility. Right? And so it makes sure that the applications that you're going to run on premises can also run in Windows Azure and run very well. Right? And so this is a big part of our strategy. It's also a big part when you look at SQL Server. It was a big part of what we focused on in shipping. And so when you look at the original exit criteria that we had for Windows Azure shipping infrastructure as a service, SQL Server was our exit criteria. SQL Server and SharePoint actually were the two exit criteria we had. And so making sure that these applications work and work really, really well has been a focal point of the team. Now, outside of that, why you may actually want to use Windows Azure to run SQL Server, well, that's kind of the concepts and the value that you get from just the cloud, right? Specifically Windows Azure, of course. The idea being usage-based and very flexible. And as you know, we recently announced even better usage-based and flexible story with our permanent billing and being able to stop without paying. And I'll go into a little bit more detail later. But the ability to spin these things up, tear them down, do them in a fully automated way using remote PowerShell, and being able to do that in a hybrid or a completely secluded environment is really what you think of when you think of why the cloud is valuable for running something like SQL. And so great examples of usage, obviously your production workloads that you may want to scale quickly in and out, but your dev test workloads also are really fantastic for a cloud model where you may want to spin it up in the morning or close it down at night. You may not understand tomorrow what you're going to need and be able to go prepare for it. Now you can just click a button and you're ready to go. And so that's kind of the cloud power brought to SQL Server, and that's what we'll be spending the day talking about. So when you look at the Windows Azure principles, there's 6 big principles that we have. The first 2 are pretty similar in the way that we approach them, which is economics and usage-based. The idea that you pay for what you use. At this point now, you pay by the minute. And with MSDN, how many people are MSDN subscribers in the room? Great, a few. How many people have activated your MSDN on Windows Azure? And how many had before this week? Okay, good. That's what I thought. Okay, great. It's good to see. So you've activated hopefully in the last week. With the new MSDN offer that we just put out, the ability to really, really pay a very small amount to be able to do a lot of this dev test is an exciting part of the offer. And again, comes back to that economics. The value of both the agility and the usage base is really strong there. For automated and elastic, this is a big part of the principles, and we push really hard on PowerShell, but we do have cross-platform solution as well to be able to deploy using Mac or using Linux as well. But with PowerShell, one great example, when you deploy a virtual machine, remote PowerShell is on by default and secure, but it is on by default, allowing you to just quickly get in there, spin up using WinRM, do some magic on the box, and be on your way. And so we do have a couple examples of that are available through our blog, and so we'll be spending a little bit more time on that as well. Obviously, the elastic approach that the cloud gives you, the easy scale up and the easy scale out. So the ability to take a VM and grow its size by just clicking on a little pull down and seeing, hey, you know what, I want a bigger VM, and it just reboot and come back up. The ability to scale out by just adding VMs. A very simple 5-minute operation, and you've got additional VMs added to your system. Real fast, real powerful. And then, of course, the managed hybrid and the high availability. From the managed hybrid perspective, the ability for you to be able to connect back on premises, either in a fully connected way or a more localized and secure way, and I'll talk about both of those offers later. And then the always up, always on is the availability approach. It's really just the fact that you shouldn't have to worry about the hardware. Right? That's our job. We're going to take care of that for you. You've got 2, 3, 4 SQL servers that you want to run. We will make sure that we're split up across the hardware, and so you don't have to worry about one box failing and causing you to see some downtime. And so I'll show a couple slides on that. So without further ado, let me actually dig into a few more details. So like I mentioned, we really focused on the IT Pro experience as part of building this service. This means a great management portal with a lot of power and ease to get going, to spin things up, and to monitor things. But we also wanted to make sure that scripting experience was fantastic. So we built a lot of work into the PowerShell solution. We also built some work into the cross-platform using Node.js. And so it allows you to spin up these VMs in sequential or parallel. It allows you to get them all going and connect them all using WinRM. And then, of course, the REST API. So underneath everything, we do have a REST, an open API that you can write to. And in fact, you could go write the whole management portal yourself if you wanted to. I wouldn't necessarily advise it since we already have one, but the whole capabilities that REST gives you is available and thus can be used as part of that portal. And so we're not using any internal APIs there. That same power is available to you. And so this is a big part of the offer, and a big part of what we want to make sure is available is that you have this power all the way up and down the stack, from REST to scripting to portal, and you can go play with it in any way you want. On top of this, we really wanted to make sure we had great support for key server applications. And as I mentioned earlier, we focused a lot on SharePoint, but we've also focused a ton on SQL. And that's, of course, the focus today. The bolded underlined lines are ones that are available in our gallery. And so you can click on these today and get them going. And I'll show you this here in 1 minute. And so with SharePoint and SQL, you've got a lot of power to get going. We also have a good set of additional Microsoft applications that we validated and made sure work with BizTalk Server 2012, Dynamics, Forefront Project Server, System Center, and of course Team Foundation Server. And so these guys have all validated that their application works and works well. BizTalk actually has an image that's available in the portal. And so with that, let me actually show you a quick tour here. Let's see if I remember which one it was. Oh, excellent. Okay. How many people have actually played on the Windows Azure portal at this point? Familiar with it? Okay, so most. I'll be pretty quick then. So you can see here on the left, you've got sort of the options of the different capabilities and different things that you can spin up in the Windows Azure platform. If you just go here to Start New, you should be able to go quickly. I'm sorry, just New. The Start button doesn't exist. Good one. Okay, it's afternoon. I'm sorry. Everyone's tired, so I thought I had to make the pitch. So you go here and you look at the gallery options, and this is what I was just mentioning. You click here to Platform Images. You can see all the different images that we've built as Microsoft and partner teams have built in Microsoft to make available to you with applications pre-installed. So the two obvious ones, the two Windows ones that we have, and we'll have Windows Server 2012 R2 when it comes out as well, and of course SQL 14 as well when it comes out. And so you can see here the SQL Server images, 2008 R2, 2012. You can go down and you can see the BizTalk images, and there's SharePoint. We also have a fair amount of Linux stacks that are available here. And you can see we have ones from SUSE, OpenSUSE and SLES. We have Ubuntu servers, and of course we have CentOS from OpenLogic. And so these are partners that have given us these images and uploaded them, and they maintain them. And so all of these images are actually maintained, they're serviced, they are up to the current patch level to make it just really easy to get going. And so let me show you what I mean. Let me actually start here with SQL Server 2012 SP1. Okay? And so I can pick my machine name. And so here you see the size options that we have. And so you can go from extra small, which is a shared core, all the way up to A7, which is 8 cores and 56 gig. We actually stopped at extra large, trying to come up with clever names for what we would call things, and just moved on to letters and numbers. Extra, extra, extra large seemed like it was getting silly, so we just came up with A7. Not necessarily that much better, but so it goes. And so you can see all the way up to A7. You can get 56 gig and choose that. I'm going to stay with small for now. And then I can pick my DNS name. Now, this is just how I would connect if I wanted it to be a public endpoint. I can always close this down if I want to, but we build in a DNS name by default. So let's see if this, those are the only options. That's right. Yep. Sorry, say that again? This is a global DNS name. So this is actually an external facing. So it ends up checking it against the whole world. Correct. Yep. Great. All right. And so then I can click through here. And as I showed you before, the enable PowerShell remoting, this is clicked on by default. That's a pretty good circle. OK. And let me just get that started. OK, while that's starting up, I'll come back. Excellent. So another big aspect that we're really focused on in Windows Azure is storage manageability and mobility. One of the things that we spent a lot of time on was making sure that you had access and could see what was running in your virtual machines. Right, so when you boot a virtual machine, the one I just showed right now, these disks are actually stored in Windows Azure storage. They're not stored on that local box. Right? And so all the reads, writes that are going through to that disk, whether they're a database or just the OS disk, are going all the way to Windows Azure storage. So what this means is that we end up just using that VHD and putting it in your storage account. So because it's just a VHD, it allows very easy mobility of that content. And so if you're moving between data center and Windows Azure Cloud, you can imagine just really moving these guys around as much as you may want, assuming your licensing applies. And that's a big part of that, is that we're just running Windows Server 2012 under the hood. So our hypervisor and our host are just running the same version that we released to everyone. Right? And so it makes sure that these things run in the same way that they would run in both places. Very powerful capability. And again, they're just VHDs. And so anything that can run a VHD or can convert VHDs, this should just all work. The other aspect, because they're in Windows Azure Storage, they end up having very high availability. Windows Azure Storage, by definition, is triplicate copies. So the disks themselves are 3 copies. So now every write that goes through is actually going through to 3 physical disks, which we maintain in the back end. So any disk fails, you don't even see it. We just redirect you to one of the other disks. Right? And so you don't even know. It's just highly available and very durable from failures. Excellent. So let me just actually come back and show you quickly that VM that's starting. So here the VM is starting. I've got a tool here. It's called Cloud Explorer. And this tool is a third-party tool that allows me to look at my storage account. And so here I have a directory called VHDs. And let me hit F5. Well, let me see here. Should be in this account. Maybe it's in here. Yeah, there we go. So what you can do here is that you can see that these VHDs that are just running in my account are stored easily accessible for me to go play with inside my storage account. And so I can do very interesting things for some of these guys that are running right now. And so you can see these guys are 328, 329. These are being written to as we speak. I can do something I can download, like I showed you with the picture. I can also copy and move to backup. I can hit paste. And so now I have just copied a 127 gig OS disk from a running VM into a backup location. And so I've just backed up my drive. Because it's all Windows Azure storage, this is copy on write, so it's effectively instantaneous. So now I have 6 copies of this guy, because this is also triplicate copied. And I'm very protected, and I can do this on a regular basis if I want to. Great. Let me charge forward here. One of the big things that we want to make sure that we enable for you is the ability to spin up things like SQL Server in a very highly available way. And the rest of the talk is going to really focus on how to do this from the SQL Server perspective and really take advantage of the Windows Azure platform in this way. But to start, it's worth mentioning sort of how we do it underneath the hood from a physical perspective. And so you can see here I've got a picture of a rack, right? And so each one of these lines here is one server. And so each one of these physical machines could die at any point. And they do die. They are commodity hardware. They fail pretty regularly. Additionally, we have one single unit in a rack and we have racks are roughly 40 machines, we have one single unit that ends up being where all of the incoming network goes through and all of the power goes through. Right? And so this single unit, which has, we call the power unit, and then another unit we call the top-of-rack switch, where all the network comes through, these are additional single points of failure, and these are real bad single points of failure because the entire rack could go down. You lose power to the rack, every machine in it goes down. And so we don't want you to have to care about that, so we care about it, and we know about it. And so what we do is we offer this capability that's called availability sets. And so with an availability set, in this case, we're aware of where the racks are, and we're aware of how to distribute load across those racks. And so when you say, hey, I have 2 VMs, these are my SQL servers, and I really want to make sure they both don't go down at the same time. You put them in availability set, and we know how to put them across multiple racks. Right? And so make sure that if one of those racks goes down, the other one stays up, and you should be fine. The other aspect built on top of this, if you were, and maybe not for SQL, but maybe for your front end that's then talking to SQL, you can also load balance. Right? And so this allows you to be able to also track your traffic to those 2 different instances, just in case one goes down. And so in this example, this rack goes down, VM1 is still up. If you have load balancing, it would redirect traffic to it. Right? And so this is how we're able to maintain it with very simple capabilities that you just have to say, put these 2 in the same availability set, and we take care of the rest. And this is how we offer our availability SLA. And so with those multiple instances, we are able to offer 395 because even with hardware, even with planned maintenance, whatever it may be, we can uphold the fact that one of these guys is not going to go down because we're able to know where the racks are and where the machines are. Excellent. Okay. Moving on. The other big aspect is hybrid networking. And we wanted to make sure that if you're going to deploy something in Windows Azure, you had a way to connect it back on premises. And so we have a few options here that make this really easy. One option is site-to-site connectivity. And this allows you to connect your entire corporate network to what you've deployed in Windows Azure in a very secure and trustworthy way. Right? And so when you spin up these virtual machines, you can define the network that they want to go into. Right? And so there's a way to be able to say, put it into this subnet, these IP addresses, etc. So you have complete control over the IP addresses that these VMs are going to get because we virtualize the entire experience. And so you can say, I have this range of IPs available in my corporate range, and so I want my cloud VMs to be in that IP range. And you can completely control that. Then as part of that, you can connect either using a hardware VPN device or even a Windows RS software device to be able to connect using a VPN tunnel. So very secure IPsec capability that allows you to connect to a gateway which we spin up on your behalf and connect to those machines as if they're a part of your corporate network. Right? So this gives you a whole lot of power to be able to connect all your on-premise devices and machines to what you're deployed in Windows Azure in an IPsec secure tunnel, right? Just like you do with any offsite corporate resource. We've actually made some announcements in this area as well, some very exciting announcements. We used to only support Cisco and Juniper in this area. We've added Citrix F5, WatchGuard, and of course Windows Server 2012 for a software device. And so this additional support just makes it all the easier to go spin this up and be able to connect in whatever way you're already doing this today using VPN. We do have a session, it was actually yesterday afternoon, MDC B406 that talks a lot about virtual networks. And so you can go watch that session as well if you're looking for a little bit more. The other big thing that we just recently announced, and this again comes back to that big focus on dev test, is what we call point-to-site. So the last example I showed you was your entire corporate network connecting to your Windows Azure resources. In this case, maybe you just want one-off connections. So maybe you just want to say, my remote workers can connect. And so this point-to-site capability is just so powerful in this way. What it does is it spins up a local remote connection on these boxes. It uses the same VPN tunnel, so it's an IPsec tunnel that connects to the gateway, but it's just per local box. Right? So there's no connectivity to the rest of CorpNet. It's just that local box that's connecting, which gives it a little bit more security. If you don't want your whole corporate network connecting, but maybe you want 2 or 3 of your developers to be able to connect every day, it gives you that power to do that. So you can do it either with remote workers, or you can even do it with folks behind your corporate firewall and say, you guys can have access to this. I don't want to open up the entire network to it. right? And so it does allow that control and that access capability without necessarily having to configure your entire network that way. And how it actually works, it changes the routes on these boxes to reconnect to those addresses that are in the cloud, making it very easy to go configure and control while still without having to set up the entire network on your local on-premise solution. And so this is a very exciting thing, again, a great thing for dev tests that we just recently announced a couple weeks ago. We actually have a lot of details on point to site in the next session after this one in this room. And there was, of course, one later yesterday afternoon as well. OK, the last thing to really talk about on sort of the overview section for Windows Azure is the IaaS paths and agility. So one of the big things that we love about our offer is not just the fact that infrastructure as a service is so powerful, and we want to make sure that it works really well for any application you may want to put in the cloud. But we also want to make sure it works well with all the other things that we've invested in that are also exciting aspects of the platform. So a great example, if you're actually using SQL databases for one of your projects, and maybe a SQL Server for another one of your projects, but you want to use the same front end that can talk to both of them, that all works. Right? That's all the same data center. It's all the same physical machines that are running these things. Right? And so it's very easy to go manage that. It's all the same bill that you get for all those items. And so you can see it all in your one portal. You can manage it all there. You can control it all there. Right? And so this is a very important aspect of what we're trying to do, is make sure that these pieces all come together in whatever way you want them to come together. And so let me quickly just show you one aspect of this. Let's see, is that the right one? So a great example of this is not even just pulling together pieces that are internal Microsoft pieces, but also pulling together pieces that may be third-party as well. And so what I always do like to spend just a minute on is showing our store. And these are great examples of platform-as-a-service options that are available, that are offered by third parties through Windows Azure. And so you can see here some great examples. You have things like App Dynamics, things like ClearDB if you want to run a database that way. Obviously not. Maybe I shouldn't talk about that in a SQL session. But some other examples that you may be interested in using. New Relic, let's say you want to use for some monitoring aspects. And so this gives that power to connect those different pieces together all in one experience. OK. And just to finish up, just a quick animation in case you weren't able to figure out what pay by the minute is. I don't know why I actually have an animation for this. It ends up meaning we don't round up. So a very elegant animation to show that we actually don't round up there. And so we give you that money back. And this is true. This is a very important point, actually. This is true for virtual machines. It's true for cloud services, web and worker role. It's also true for SQL Server per hour and BizTalk per hour. So all of these aspects we don't round up anymore. For things like BizTalk and SQL Server, that's quite a bit of money that you can save, especially if you're turning them on and off on a regular basis. And then the last one that is worth just calling out, for MSDN, MSDN products are now supported to be run in virtual machines. So if you have access to Visual Studio, SharePoint, et cetera, you can just go and install those in virtual machines. It used to not be allowed. There's also the change as the single monetary credit. And so you're able to take a single dollar amount and be able to spin it on anything you want to. Before, it used to be a pretty convoluted list of this and that and piecing it all together. Now you just get money and you get to spend it. And with that spending, of course, is really dramatically reduced prices. And so I like to focus on this. You look at SQL Enterprise here. The pricing has reduced from $2.19 an hour to 6 cents an hour if you're running it for dev tests using MSDN. It's a pretty gigantic drop. Obviously, we highly recommend you play with this and spend some time on it. And 97+% savings. Great. And then we have more focusing on dev tests here in the next session after this one. So great. Without further ado, let me pass it along to Luis, who's going to spend some time talking about SQL Server HA on IaaS. Yeah, of course.
OK, can everybody hear me? OK. So that was a great overview of Windows Azure. Now let's move into specifically how do we protect SQL Server and how do we ensure high availability as well as disaster recovery for SQL Server workloads. So I'll be talking about 3 scenarios. The first one is how do we ensure high availability for all SQL servers within Windows Azure. Here what we want to do is have one or more replicas of SQL Server running within the same Windows Azure data center, so that in case that the primary SQL Server goes down for some reason, you have other replicas that you can use to continue running your workloads. The second scenario is disaster recovery for your on-premise workloads using Windows Azure. So this is a very, very interesting scenario. So this is where you want to protect your SQL Server in your company, your organization, and you don't want to expand a new disaster recovery site because it's very expensive. So in order to do this, you can use Windows Azure, for example, to have a replica of your database that is running in the cloud and that you can use in case of a disaster occurs. And the final scenario is, in case a disaster impacts Windows Azure, how can you go and protect your SQL Server workloads so that you can run as quick as possible in a different Windows Azure data center? So I'll talk about what Windows Azure provides, what the platform provides, and what are the things that you can do from the SQL Server perspective to increase even more the numbers of high availability and disaster recovery. So let me talk about the first scenario. So protecting SQL Server within Windows Azure for any failures. So why do you want to do this if the platform already provides some high availability, as Corey was describing? Well, the first reason is that Windows Azure provides the VM itself. So if the host machine fails for some reason and the VM is impacted, Windows Azure has a way to basically service heal that VM so that that VM is available in some other place. Now, this doesn't protect you from SQL Server, for example, going down. Right? The SQL Server service could be hung. It could run out of memory, for example, or the SQL Server service could crash in a bad way, for example. Normally it doesn't happen, but it could be the case. How can you protect from that? So in order to protect from that, you can have a SQL Server specific high availability solution that detects those failures, and we'll talk about how you can configure that. The other thing is, if the host fails in Windows Azure and the VM is service healed, that basically means restart in a different host, that process takes around 12 minutes. If you have a SQL Server replica that is online and is available, you can just fail over to that replica, and that'll take seconds, right, instead of minutes. So it's a good thing to do. The other thing is Windows Azure will do upgrades, right? So it's required to upgrade the platform from time to time. And every time that this happens, the host machines basically need to be upgraded, and all the VMs in those machines are restarted. And that restart takes around 15 minutes, right? So if you want to protect and ensure high availability of your SQL Server workloads while this happens, you can use SQL Server high availability technology. So how does this look like? So this looks basically like this. You have your primary SQL Server, right? It is running in a VM, and all your workloads are executed there. And then you have one copy of your database in a different VM. In case there is a failure in this VM, or SQL Server fails for some reason, the other SQL Server becomes the primary. And eventually, once the previous VM comes back online, it starts synchronizing workloads from the primary, and it becomes a secondary, so that now you have, again, high availability for the new primary. Does that make sense? Okay. So this is the same concepts that we have today on-premise, so you're probably familiar with this. What are the technologies that we support in Windows Azure for high availability? We support two. Anybody familiar with availability groups? Always on, right? Some people. Okay. Database mirroring, people familiar with it? Yeah, okay. So we support both solutions. In terms of some of the characteristics of this, availability, both of them ensure no data loss. This means if there is a failure, we will guarantee that you don't lose any data, right? In terms of what is the scope, this is what do they protect? Well, database mirroring protects a single database, so you have to configure these database mirrors for every database. Availability groups protect multiple databases, so if your application depends on 3 or 4 databases, you can put all of those databases in the same availability group, and then the availability group will ensure that all of those databases fail over together. Right? In terms of the number of secondaries, with mirroring, we have only 1. With availability groups, you can have up to 4 secondaries. Both of them provide automatic failover. Right? So in the case that there is a failure, we automatically fail over to the replica. And in terms of what you can do with those secondaries, with database mirroring, people historically have created database snapshots to run reporting workloads, for example. This has become native with availability groups. So with availability groups, you can just configure each of these replicas as readable, and you can just go and start reading from them. So you don't have to maintain snapshots or anything like that. So in terms of availability groups, you have many other capabilities that you didn't have with database mirroring, and this is why we recommend our customers to use them. Some of these are flexible failover policies. This means you can actually configure the level of failures that will cause an automatic failover to occur. And this can go from the SQL Server service goes down to SQL Server is out of memory for more than a minute, or you have like many different types of levels that you can specify. So you can have very fine-grained conditions of what will cause a failover to happen. I won't go into a lot of details here. Things like backup on secondaries, you can start moving your backups out of your primary. So those IO-intensive operations can now be executed on the secondaries. Manageability is improved, and I'll show you that in a demo. You have support for new features like file stream and file table that we didn't have with database mirroring before. Some considerations. Availability groups require Windows cluster. So before you configure availability groups, you need to configure Windows cluster. It doesn't require shared storage, though. Each of these VMs, all they need is to have some local attached disks that they can use, and that's all they need. However, Windows cluster requires that these VMs are part of the same Windows domain. So basically, this means you need to have an Active Directory domain controller available for your domain. And I'll show you this in the demo. People who are familiar with availability groups, they know that we have a concept called availability group listeners, and this is basically just a DNS name, a single name that applications can use to connect to the primary, irrespective of how many replicas you have. Irrespective if you have 3 or 4, you have a single name. We don't support this yet in Windows Azure. We have a dependency on having something called floating VIPs, which is basically virtual IPs that can move from one VM to the other. And we don't have that yet. It's coming in the next couple of months. So we're working hard on this, and it's coming very soon. In the meantime, basically, how your clients connect to the primary, how do they do it? Well, they do it in the same way as we did it with database mirroring before, which is called failover partner. This means in your connection string, you specify 2 replicas, one primary and one secondary. And then the connectivity driver, ADO.NET, for example, or ODBC, will try to connect to both of them, but it will only connect to the primary. So this works great for automatic failover, and you can do this for automatically reconnecting to the primary. However, the limitation is this only supports 2 replicas, right? So if you can only find the primary out of 2 replicas. So in a couple of months, we'll have the listener, and then you'll be able to find the primary, all of the total number of replicas in the availability group. Okay. So what do you need to do if you want to go and configure either database mirroring or availability groups in Windows Azure? So the first thing that you need to think about is how do we go and provision these VMs so that they are highly available, right? And Corey talked about some of these concepts. So 3 things that you need to think when you provision these VMs. You need to make sure that you add these VMs to something called affinity group. These concepts are Windows Azure concepts. By putting them in the same affinity group, what this ensures is that they're part of the same Azure cluster. And this will basically reduce the log synchronization between your primary and your secondary. So this is making sure that they're part of the same Windows cluster. The second thing is making sure that primary and secondary are part of the same availability set. Again, this is the concept that Corey was talking about. This ensures that primary and secondary are in different racks, so that in case one rack fails, it doesn't impact multiple replicas. And also in different upgrade domains, so that a Windows Azure upgrade only impact at the same time at most one of these replicas. And finally, ensure that these replicas are in the same virtual network, the same VNet. And the reason here is that by putting these VMs in the same VNet, Windows Azure will ensure that the IPs of these VMs don't change, right? If you don't put them in the same VNet, and the virtual machine, for example, is service healed and is restarted in a different host, the IP of that VM may change or will likely change. And because of that, the DNS needs to be updated because of that. So it takes around 12 minutes for the DNS to be updated. So it's 12 minutes that your applications may not be able to connect to names. So putting them in the same VNet ensures that you don't have to update the DNS entry. And also, VNet is a requirement for Active Directory. So if you use, for example, Windows Authentication, if you want to use Windows Authentication to authenticate your users to SQL Server, that means that you need to configure an Active Directory domain controller. And for that, you need to have a VNet in place. So going a little bit more into detail here, this is probably a lot of detail, but in the slide, you have all the different links to all the different information that you can look into detail. So if you want to configure availability groups in Windows Azure, what do you have to do? Well, the first thing is you have to set up your Active Directory domain controller. Right? I'll show you in the demo a configuration that has this in place and how it looks like. Then you need to add your VMs to the same domain. You need to configure your Windows cluster. Right? Something to consider here today is that when you create a Windows cluster, anybody has created Windows clusters before? Has configured clusters? Okay, some people. So when you create a Windows cluster, by default, the Windows cluster will try to get an IP for something called the cluster network name. Right? So the network name is a DNS name that you use to connect to the cluster, and that requires an IP address. Again, today we have a limitation that we only support a single IP per VM. So if you try to, when Windows cluster tries to request this additional IP, that request will fail. So in order to avoid any issues with the Windows cluster creation, what we have done is we have provided a script to our customers. You can find this online. It's called the Create Azure Failover Cluster script. You have the link here. And basically, this will work around that request, right? So that request doesn't take place and the Windows cluster is created successfully. Once you go and configure Windows cluster, basically, you need to go and configure availability groups in the same way as you do it on premise. We have tutorials here. So we have tutorial for PowerShell. We have a tutorial that shows all the screenshots. So you can go and do that. So before going into a lot more detail here, actually, let me show you a demo. Probably it's going to be more interesting to see it in action. Okay, so the first thing that I have here is the Windows Azure portal. I have some VMs here that I'll be using in the demo. Contoso DC1, SQL, SQL1B. So let me click on one of these ones. So this is actually the VM that hosts my Active Directory domain controller. And the only thing that I wanted to show you here is if I look into configure, you'll see that this domain controller is part of an availability set. Again, this is the concept that Corey was talking before. Right? In the same availability set, I have other two VMs. The first one is the VM that hosts my primary SQL server, and the second one hosts my secondary SQL server. So by adding these VMs to the same Windows Azure availability set, I ensure that they are highly available in the platform. Another thing, you can see that they are part of also the same virtual network. Right? So now I can go into one of these. So let me go into the domain controller. So as usual, domain controller, just as you have it on premise, this one is running in the cloud. You can see that I have 3 computers accounts. The first one is the one for the cluster. Once you go and create the cluster, this creates this computer account. And then I have 2 more. These are the 2 VMs that are hosting my primary and secondary replicas. In terms of users, the only thing that I have done here is I have created 2 users, one for each of the SQL Server services to run. Right? So once you have configured your Active Directory domain controller, I can go and connect to one of my VMs. So let me connect to my primary SQL Server. Right? So this is one of them. And what you can see is that I have configured an availability group. Right? The availability group is protecting 3 databases in this case. So if for some reason SQL Server becomes unavailable, these 3 databases will fail over together to a different SQL Server. And you can see that I have 2 replicas. I'm currently connected to the primary, and I have 1 secondary. You can see more information about the configuration here. These are configured as synchronous replicas, right, to ensure that there isn't any data loss. They're configured for automatic failover, so that in case that one fails, the other one becomes automatically the primary. So at this point, what you can do, for example, is we can go into the primary and shut down SQL Server. I'm going to stop the service here. So this will stop my primary SQL Server. And what will happen is the secondary SQL Server that I have will take the role of the primary. So once this takes the role of the primary, now my workloads can connect basically to this replica and can continue running there. So the main thing here is for you to understand that failures that impact SQL Server will not be detected by Windows Azure, and you can protect this by configuring an availability group. So at this point, let me go back to use the presentation to. Okay. So we talk about configuring availability groups. In the case of database mirroring, if you need to have Windows authentication, then you need to set up your Active Directory domain controller. If you don't need Windows authentication and you only need certificate authentication, for example, you don't need to set up the domain controller. Again, we have a tutorial with PowerShell of how you can go and automatically provision this so that when you provision your SQL servers, you can configure database mirroring as part of the provisioning. All right, so I'm going to hurry up a little bit because we still have a lot of customer scenarios. We want to talk about how customers are using it. But let me talk about probably one of the most interesting scenarios that customers are looking at. This is providing disaster recovery for their on-premise SQL servers is in the cloud. And the reason is that your on-premise SQL server may become unavailable for different reasons. This can be temporarily, so there may be a gateway failure, for example, and your SQL server may not be accessible, or this can be permanent, for example, in the case of flooding. And we have cases, for example, in New York after the flooding that we saw many customers having to do failovers from one data center to a different data center to continue running. Now, the problem is having these disaster recovery sites is expensive. You need to pay the rent of the site, maintenance, hardware, and operations people. So what you can do is simply go and span a new copy of your databases, a new replica, into Windows Azure, and have that available for disaster recovery purposes. So the main scenario that you will have is on-premise you have your primary and one secondary for automatic failover. Right? This ensures your high availability. So as soon as there is a failure, in seconds you can connect to the new primary. But you may want to have another secondary in Windows Azure for disaster recovery so that in case that the whole on-premise environment becomes unavailable, you have a copy in the cloud. These replicas in the cloud synchronize continuously from your on-premise databases. And you have the freedom of putting these replicas in any region that you want in Windows Azure. So you can put them West US, East US, Europe, Asia, etc. Where you want to put them will depend on potentially political considerations. So in some countries, they require you to have your replicas within the same region, or also because of latency. So you may want to have these replicas in a region that is close to or not very close because you may not want it to be impacted, but relatively close so that latency doesn't increase substantially. All right, so just to close here, we have some customers actually that are inverting the deployments. So in some cases, they actually have the primary and the secondary running in Windows Azure, but they have the disaster recovery side running on-premise. And when Sanjay talks about the customer scenarios, he'll talk about why some of them decided to do that. Again, in terms of the technologies, you're probably familiar with this, nothing new. We support availability groups, we support database mirroring, and we support log shipping. So you can configure all of these technologies between your on-premise environment and Windows Azure. Again, in the case of availability groups, there are some benefits, and that's why we tell customers to use them. The first one is availability groups allows you to have multiple replicas. So you can have, for example, in the same availability group, one local replica for high availability and another one for disaster recovery. If you don't use availability groups, then you'll probably do what you have today on-premise, which is combine failover clusters and database mirroring, or database mirroring and log shipping. So you have to combine different solutions. The other advantage of using availability groups is that those replicas are available for read workloads. So if you have those replicas in Windows Azure, you can actually use them to put some of your reporting workloads there. You have BI application, business intelligence. You can run them in the cloud. The other thing is you can start offloading backups to Azure. Right? So if you have your replicas in Azure, you can start creating backups in those replicas in Azure, and you can now maintain backups in the cloud. So some people, some companies have some policy compliance reasons of why they need to maintain backups outside of the main data center, and they can use availability groups for this. Just remember, it requires these VMs to be part of this, these replicas to be part of the same Windows domain, and they're required to have an active domain controller. So either you add that Windows Azure VM to your on-premise domain, or you set up an Active Directory domain controller in the cloud. What is required to configure this? as Corey mentioned, you need to configure basically a VPN, a virtual network between on-premise and the cloud. This can be either through a physical device or Windows Server RAS. And after that, you go and configure these technologies in the same way as you do it on-premise. So we have tutorials for all of this. I won't go through the steps at this point, but it's the same thing as you do it on-premise. So let me show you a demo. So what I'm going to show you here is this deployment. So on-premise, this is actually in Redmond. I have an availability group with 2 replicas, one primary and one secondary. These are part of one domain in Redmond. And then we have configured this VPN tunnel between on-premise and the cloud. And in the cloud, we have one replica, right, which is configured as a secondary replica and which is continuously synchronizing from on-premise. So let me show you the demo here. Okay, so what you see here is I have one availability group, right? It has 2 replicas. I have one primary and one secondary, right? And then I have another secondary called AG Cloud Replica, and that's the secondary that I have in the cloud, and I'll show you that in a second. You can see the configuration here. Primary and secondary are configured as synchronous and automatic failover, again, to ensure high availability, ensure that I never lose any data. But my secondary in the cloud is configured for asynchronous commit, and what this means is I will not block any transactions on the primary, waiting for the acknowledgments back from the secondary. And this is to ensure that I don't have any increased latency in my transactions on the primary. Right? And this is configured for manual failover. This means if for some reason I have a disaster and I cannot connect to my on-premise SQL servers, I can go to that machine in the cloud and then manually fail over to that machine. And then my applications can continue running there. You can see I have a lot of information here in SQL about what is the state of these replicas. I can see that they are synchronized. In this case, the one that is asynchronous is telling me that it's synchronizing. They tell me that for the first 2, there is no data loss. In the case of the one in the cloud, there is potential data loss because this is asynchronous replication. Right? How much data loss I will have? I can look, for example, at the last commit time. When was the last time that each of these replicas committed a transaction? I can look at what was the last log sequence number that was committed in each of these replicas, and I can compare them. So I have a good understanding of the number of transactions and when was the last time that each of these replicas committed a transaction. So what I can do now is go into the portal just to show you that this is actually in the cloud, that I'm not lying here. So I can go here, and then we can look for that machine. And you can see that this replica is just a VM living in Windows Azure, right? AG Cloud Replica. I can RDP to that machine, right? So I have RDP here. You can see the DNS suffix that this is running as part of the cloud app.net, etc. DNS domain. And now what I can do is I can actually look at my databases here. You can see that I have this database that is part of the availability group, and I can just go and run queries from this. So you can see I can actually use my replica in the cloud, just continually run queries. So in this case, I'm running a query from one table. I can go back to my on-premise machine. Let's see what this one has. Oops, I need to connect to the right machine. So it's connecting to the secondary. But I'll connect to the primary, and then we can execute basically the workload. So okay, I think I'm connecting to the wrong one. Let me just give me 1 second. But what I wanted to show you here, new query. Let me see. Yes. Sorry, I was connecting to the wrong one here. Yeah, let me try this one again. Okay, yeah, I was connecting to the wrong one actually. So I can select here from this one. Okay, and I can see that I have 15 values here, for example, right? So if I go back now to my machine in the cloud, and I execute this one here as well, you can see that I have my 15 values as well. So every time that you go and insert records, this is this continuous synchronization from the on-premise to the cloud. So how long it takes? Well, it takes depending on the latency that I have between those machines. But in general, you can expect 1 to 2 seconds of latency before these records got reflected on the secondary. So yeah, let me go back to the presentation. Obviously, at this point, if there was a failure on-premise, I could just connect to my secondary in the cloud and do a failover there, continue running. So in terms of time, let's see what's some time. OK, let me talk about the final scenario. This is how do we ensure disaster recovery for SQL Server in one Windows Azure data center in case that I want to continue running as quick as possible in a different data center. So the platform already provides disaster recovery protection for you. However, there are certain limitations that we have to consider from the SQL Server perspective. So if your SQL Server uses multiple disks, remember each of these disks has a limitation of 1 terabyte. If for some reason your database is larger than 1 terabyte and you require multiple disks, the Windows Azure geo-replication between Azure data centers doesn't guarantee write order across these disks, right? So in case there is a disaster and we try to restart SQL Server in a different data center, there could be potential problems when you try to restart SQL Server because it's possible that there's some data that is not reflected in the log if you're separating data and log files across different data disks. So because of this, you may want to have a specific SQL Server solution for disaster recovery in Windows Azure. Another reason why you may want to have this is if the SLAs that we have, well, actually we don't have SLAs, but if the expectations that we have from Windows Azure do not satisfy your particular requirements. So, for example, some of the times and numbers you can expect are here. So in case of there is a disaster in Windows Azure, it can take around 24 hours, for example, to span those VMs in a different data center. Data loss can go up to around 30 minutes. So if these are requirements that you want to work around, you may want to have a SQL Server specific disaster recovery solution. Another reason why customers want to have this is the freedom to test and execute disaster recovery at any point they want, right? So if you want to go and test disaster recovery on your own time, you may want to have your own disaster recovery solution that you can try. Basically, the way this looks like is you can have, you'll have your primary SQL Server running in one Windows Azure, and then you can have a secondary SQL Server running in a different Windows Azure. Now, let me talk about the technologies that we have support for today. So today we support database mirroring, right? And we support a new feature called backup to URL. I don't know if you're familiar with backup to URL. We just released this in SP1CU2 for SQL Server 2012. And what it allows you to do is take a backup of your database and restore it in a Windows Azure storage, right? So these are the two solutions that we have at this point. So you either have one database mirroring copy in a different data center, or you can take a backup from your database and restore it in a different data center so that that backup is available to be restored in a different data center in case you want that. We don't support availability groups yet. We're working hard on this. The reason is that for availability groups, we need these VMs in the different Azure data centers to be able to be part of the same Windows domain. So we're going to support this later this year. In the meantime, if you want to have your SQL Server disaster recovery solution in place in Windows Azure, you have different options. The first one is if you're using a single disk, then just take a dependency on Azure Storage geo-replication, right? So the platform already protects you. If you want to have your specific SQL Server disaster recovery solution, you either have database mirroring, but again, the limitation is database mirroring supports a single copy. So if you want to use it for disaster recovery, unfortunately, you cannot use it for high availability. So that's one limitation to consider today. Or the other thing you can do is take a dependency on backup to URL, where you're taking a backup from your SQL Server in one Azure data center and storing the backup in a different data center. The other thing that we have some customers doing today is they actually have availability groups running from Windows Azure to their on-premise domains. So they actually have the disaster recovery replica on-premise. In terms of what you need to do if you want to configure, for example, database mirroring across different data centers, the only thing that you need to do is for those VMs in the Azure data centers, you need to configure a public endpoint so that they can connect to each other. After that, the configuration is as on-premise. You can just connect them. And again, we have a tutorial of how you can do this. So at this point, I'm going to pass this to Sanjay, and he'll talk about the customer deployments.
Thanks, Luis. Thank you. How many of you have had a chance to play with creating a high availability within Windows Azure VMs? Anyone? Okay, so you'll like this example. So Luis took you to the very depth of how to get things done, demo of the things, how each of these constructs work. I'm trying to take you a level up, get a high-level view of how some customer are trying to deploy it. As you know, we had Windows Azure VMs in preview since last year around this time, and a lot of customers have been playing with this. And then we have it under GA for over 6 weeks now, and we have several customers in production. I'm going to show you some examples, and some examples of this customer. Real customer, we will not be able to take their names now because we are working with them to produce different case studies, and once we have those case studies prepared, we can actually use their names. And once and some of them are under proof of concepts level, some customers are already in production, and you will see both kind of examples. And I'm going to talk about an online travel firm, a leading car manufacturer, an online video streaming company, and a healthcare CSB. I can probably guarantee you have used product and services of at least one of these in your life. Definitely, yes. So you can see the kind of high-profile customers are these. A quick touch point on what some of the customers that we worked with did right or wrong. What do we learn from them? Number one, how many of you know the difference between availability sets and availability groups? Everybody clear on that? Okay. For those who are not, let me repeat. Availability sets is a Windows Azure concept. It's a concept at the VM level. You can put multiple VMs together in an availability set. Availability group is a SQL Server concept. You build availability group among SQL Server instances to provide you high availability or disaster recovery for your SQL Server databases. And you need both. If you're setting up SQL Server high availability involving Windows Azure VMs, you need both. And some customers were a bit kind of tough to get into their system, and they think either or is okay, or probably if I do one and then I'm good with the other. So that's one important concept. The second concept that we learned working with these customers is reading the documentation and reading the right documentation. How many of you have deployed availability groups on premises? Good. There is slight difference between how you deploy it on premises and how you deploy it in Azure VMs. Some customers try to read the extensive documentation that we published for on premises and ran into a few gotchas. One of them is how do you create the Windows Server failover cluster? And creating a Windows Server failover cluster for on premises, you go to failover cluster manager GUI and do a few clicks and you are done. That will not work with Windows Azure VM as of today. Eventually it will someday, but as of today, Luis provided a link to a special PowerShell script that we provide you. Please use that to create the required Windows Server failover cluster to be able to create availability groups. And also read the documentation specifically we have created for availability groups in Windows Server VMs. Okay, what does this travel firm do? It's one of the leading tour operators in Europe, and they sell trips to various locations in Europe. As you can see, they had over 700,000 passengers in 2011. What do they have today? They have one data center in one European cities, and that's their primary data center. They do not have a DR data center today. And as Luis pointed out, building a DR data center can be cost prohibitive to some customers. So what they try to leverage, Azure as a DR data center. So what they have today is this. This is in live, in production, running for a year and a half at least, and they have it on premises, 2 replicas, primary and secondary. They want to augment this with a replica in secondary putting this in Azure. And this is they have completed proof of concept for this, and it would be going live pretty soon. A leading car manufacturer, this is one of the largest car manufacturers in the world. This customer went live last week. And this application is a car live portal experience. You can, various of telemetrics from the car portals are being updated to it. And they also create a social network among various car owners from this company. What they have deployed today is 2 Azure VMs within Azure. And once we have availability groups listeners working, they will extend it to more replicas. An online video streaming company. This is a company that is, the name itself suggests what do they do. What's important for them is HADR is important. You don't, a Friday evening when people are watching video, you do not want them to have a downtime while streaming. They will be using Azure as their primary data center. However, they will be using one secondary in their on-premises data center as a DR. It's look like this. Azure will be used as a primary, and a secondary in on-premises. A proof of concept is already completed for this, and they will be going live pretty soon as well. This is healthcare CSV. This is a pure lift and shift model. They want to have exactly the same application running on-premises as well as running on Azure. And being a healthcare application, they need HIPAA compliant. Windows Azure VMs and SQL Server running on Windows Azure VMs is HIPAA compliant. Anybody from the healthcare industry here who come across this kind of regulatory complaints or regulatory requirements? Please note, HIPAA compliance, Windows Azure VM, SQL Server running on Windows Azure VM is HIPAA compliant. And that's why they picked this solution. And they'll be running primarily on Azure. They would be using on-premises to keep a secondary copy because they need to do some kind of reporting from on-premises, and that's the regulatory requirements. Looks pretty much like the previous one. The requirements are slightly different, but end solution is the same. What you saw here is that varied degree of customer, varied kind of businesses, they are gearing towards the similar kind of application architectures, either using on-premises as primary and using Azure as secondary, or using Azure as primary and on-premises as secondary. So this kind of hybrid model gives them the flexibility to run their application which is the best suited for them, and have a DR copy which is again best suited for them. Yes, you have a question? The question is, are they running virtual machines on Windows Azure? These are all about virtual machines running on, the entire session today is about virtual machines running on Windows Azure. Oh, the question was about domain controller? Okay, so for those who are running only within Windows Azure, the entire HA is within Windows Azure, those cases the domain controller is within Azure. For the customer who have on-premises and Azure hybrid, they have the domain controller on-premises, and what they use is the gateway and the virtual network tunnel, VPN from Azure to on-premises, so that they can join those Azure VMs into the on-premises domain and create the Windows cluster that they need to be. Does that answer the question? Yeah, thank you. So what you saw is that the customers, various different range of customer, different range of applications, leveraging Windows Azure VMs and SQL Server and the hybrid model to provide the HA and DR needs. Yes?
So earlier on you were talking about what is being done in our app, dev test, that sort of thing. Especially show up to the customers of the big like production.
Absolutely. The question was, some examples were given for dev test, and this is production. These are real production. A couple of customers already live. Some customer proof of concept done, they will be live pretty soon. So these are production workloads. One quick note on, there was a bullet point in earlier slide about choice of data center, where you put your DR. A customer I worked with, they have the primary data center in New Jersey, the secondary in New York. Hurricane Sandy happens, the primary and secondary both are affected. And they wanted to choose a data center which is far away, even though latency gives them a different metrics, but they want a data center which is far away, which cannot be impacted by this kind of disaster. Another customer which I showed in one of the slides, they have the data center in one of the cities where we have our Azure data center. So the primary data center is in that city. So they choose an Azure data center which is a different city, so that they can have the true disaster recovery in case of a failover scenario. So those are the things that you take into account when you design an HA or DR solution for your SQL Server databases. I have a few minutes left. I'll hand it over back to Luis. He has a very interesting demo to show up, and then we'll be sticking around for more quick Q&A. Thank you.
Okay, so we say actually the coolest demo at the end. So let's go through this one. So we talk about all these hybrid scenarios and adding these replicas in the cloud, and then I show you some links, and there are some guides that you can go and follow. But wouldn't it be great if we could just simplify that, if it was as easy as just like running a wizard or something like that? So let me show you what we are doing in SQL 14 actually to simplify this scenario. So again, going back here, this is the same SQL Server that I showed you before. I have one availability group. It has only 2 replicas on premise. Right? I have one primary and one secondary. Now let's say that I want to add another secondary in the cloud. So what can I do? Well, in SQL Server 14, what you can do is right-click and say Add Replica. Right? And this will bring the traditional wizard that we have today for adding a replica, where I can add an on-premise replica. But what you will see is that we have new functionality here, specific for Windows Azure. We have an Add Azure Replica button as well. So if I click Add Azure Replica, you will see that this wizard automatically remembers that I had connected before to Windows Azure. It remembers my certificate that I used to connect, the subscription that I use. If I don't have a subscription yet, I can just connect to Windows Azure. Sorry, if I don't have a certificate yet, I can connect to Windows Azure using my login and password, and I can download my certificate and subscription. After that, I can connect to Windows Azure, and what this will do is SQL Server will connect to Windows Azure, to my subscription, and it will download all the information about my subscription. It will download, for example, all the different images that I have for VMs, to create VMs, the sizes of VMs, the different networks that I have available for connectivity and things like that. So, for example, here, I can select, if I want a new replica, what is the SQL Server VM that I want to use, the image. In this case, the wizard knows that I'm running SQL Server 2012 SP1, and because of that, it selects the right VM image in the cloud. I can select the size of the VM. So I can say I want, for example, a medium VM with 2 cores. Right? My replica is going to be running like that. I can give a name to the VM. I specify the administrator password that I'll use to connect to that VM if I want to administer it. Then I can specify where do I want that VM to be created. So my network administrator has already created different virtual networks, right, to the different Windows Azure regions. And I can see, for example, that I have networks to West US, East US, North Europe, Asia, etc. So in this case, I'm going to say I want this in West US. I want to use this particular virtual network. Again, network administrators define subnets. He can tell me put it in this subnet, or I can put it in the subnet I feel like. And finally, I can specify my domain credentials so that that VM in the cloud is added to my on-premise domain. Right? This, again, is a requirement that we have today in order to build this cluster across different virtual machines. So I'm going to specify here my domain password. And after that, you will see that I have now in the list of replicas a new replica here that is going to be configured in Windows Azure. Now I can specify if I want this replica to be readable or not, just by saying yes here. that replica in the cloud will be readable, and then applications will be able to connect to it and read from it. So I can say yes, and I can say next here. Now the next thing is, how are we going to move the data from on-premise into the cloud? Right? So you need to start that replica somehow. So by default, the easiest option is to select full synchronization here. And what this will do is it will take a full backup of my database, right? Share it in a network share, and then move that backup and restore it in the replica in the cloud. So again, depending on the size of the database, this may take a few minutes to a few hours. After I do this, basically this wizard will go and do a bunch of validations, right? So I will probably not entertain you through all the things that are going here, but the idea is like every wizard will try to ensure that at the end of the wizard you have success. So we're going to validate things like making sure that you have enough space in the VM, that the production deployment where that VM is going is healthy, that VM the name doesn't exist yet, either on premise or in the cloud, et cetera, et cetera, et cetera. So this wizard will go do a bunch of validations, and at the end it will go and run all the steps that today you have to go and do manually. So I probably won't entertain you doing all this, but at the end, basically what you will have is the replica that I showed you before. So actually the one that I showed you, this one, AG Cloud Replica, was configured using the wizard, and that's how you can have this replica running in the cloud. So you have any questions? Yes?
The actual backups, we were talking about snapshots,
Yeah.
backups. How does that affect the actual cost?
How affects what, sorry?
The pricing. So I'm paying for, one VM with like 2 cores. How does that affect me every time I make a backup or every time I want to
Right, so you're talking about taking backups from those SQL servers in the cloud. So every time that you take a backup and you have to store it in Windows Azure Storage, you'll have to pay for that storage.
With one important caveat there, which is that Windows Azure Storage is sparse, so you end up actually paying for the rights that you make from that point forward, right? So if you're copying, and so if you have let's say a blob that's a terabyte, but you're only actually writing to 50 gig of it, you only pay for the 50 gig that you're writing to. So there is that sparse aspect of that billing model.
Yes?
How do you control upgrades? So let's say you're replicating on certain SQL 12 into Azure, and you want to migrate to SQL 14.
Right.
Is there considerations for an upgrade path?
So yes, it's the same process that you follow on-premise today. What you do is you do something called rolling upgrade, which basically means you upgrade your secondary first, right? Then you fail over to that one, upgrade your previous primary, which is now the secondary, and then you can fail back to that one, right? So this is how you reduce downtime while upgrading the full deployment. Any other questions? Well,
Great. I
Thank
guess
you.
that's it. Thank you guys very much for your time. And enjoy
Appreciate
the
it.
rest of TechEd.